Hello, statistics student. In this video, we're going to cover 2.7, which is the measure of spread of data or variations. In more technical term, it's measure of variation. But this is the topics in the book, so I use this title. A measure of variation is to describe how data vary, the degree of variness. So in a nutshell, so maybe what I can do is if I have a list of scores, from a quiz, so everybody is like 7, 8, 7, 8, 9, 8, 8, 8. So you can see the data are not very varied. They cluster around this. But if I have score out of 10, okay, so this is one group of student, the other group of student is like 1, a group of 5, and then 8, and then 10, and then 2, 4, and 9. So this is also, you can obviously feel that these data are very varies. So we would say that these had a high degree of varies. The degree of variation is high. This degree of variation is low degree of variation. So we want to measure. So if we are given a set of data, we want to measure how, not the value of it, like the mean is, but the degree of variation. And there are three three summaries that we can use. The first is called the range. The second is called the standard deviation. The third is interquartile range. The range is what you know in common sense. It's just the maximum and the minimum's difference. So your maximum value of the whole data set minus the minimum value, that is the range. What is the range property? It is not resistant. So if you have a data that is extreme, then you would feel that the range is very large, but it does not actually um, measure the degree of variness of all the data. Just like when we talk about the first one, right? You can see that if all of a sudden I have a 0, so all these are not very varied, but one extreme data would make it as if they are very varied. Okay, so it is not resistant, affected by extreme data. And it also only look at the max and min. The second one is a little better. It looks at every single values. And the way to calculate the standard deviation is we look at how each data is away from the mean. So the mean is our kind of like a middle point. And if we say, well, it is very varied, that means all the data are away from the mean. Just like when we have earlier, I don't know what the average of this data is, probably 8, right? So if the average is 8, so how many data are actually close to the 8 and away from 8? They're all very close to 8. This, I don't know what the mean is. Probably the mean is 4 or 5, but you can see 1 is very away from 5, 10, 9, and 10 is very far away from 5. So they use this idea of calculating a summary, which is, so look at this formula, x minus x bar. So I'm going to write it out. So every single value, x is a value, subtract from the x bar. Everybody remember x bar is the mean. And then we square it because if you are lower than the mean, you will have a negative number. So we don't want to add negative number. And then you add them all together. You add all the square together and you divide it by n minus 1. N minus 1. N is the sample size, the number of data that you're adding together. But we don't divide by n, we divide by n minus 1. And then after we do that, we take the square root. Why? Because you're adding a whole bunch of square together. And if n is a sample size, n minus 1 is called the degree of freedom. Okay, so why do we divide by n minus 1 instead of n? Has to do with if you just divide it by n, the data tend to be, if you divide by n, the data, variation seems tend to be smaller. So if you divide by n minus 1, you would have a bigger number. Okay. So this is a number. It's the difference of all the distance. You can think of if you plot a dot plot of the data value, like all the data are in a dot plot. These are the data value, right? And then these this is the mean. Say for example, this is the mean. Okay, this is x bar. So what we're doing is measure how each one is away from the mean. Okay, this is 1 away from the mean, this is 1 away, this is 2 away, this is 3 away. You square the distance, you add them together, and you divide it by the number of data minus 1, and you take square root. So what is the property of this number? And we call it standard deviation. If the data is from a sample, it's called sample standard deviation. Sample standard deviation. The symbol for it is S. So it does have a symbol, just like mean has a symbol of X bar. Sample standard deviation is S. Not very special, but they use English alphabet. And then later on, we'll learn that for population standard deviation, they would use a Greek letter. So later on, we'll talk about. So let's go through the properties of a standard deviation. Because you're adding square number together, S is never negative. If all the data are the same value, then standard deviation is 0. Just imagine if you have all the data like 10, 10, 10, 10, 10. You have a few data value, but they're all 10. Do they vary? They don't vary. They just become 10, right? X bar is 10. The mean is 10. So everything single data is 0 away from the mean. So you add 0 together is 0. So if your data don't change, the sample standard deviation is 0. So what is the unit? Is the unit is the same units as the original data. If this is dollar, if the data is dollar, the standard deviation is also dollar. And also if your data is really spread out, then you have large value of S. A small value close to 0 means the data are not vary. Just like mean, would also increase dramatically with one or more outliers. Just imagine if I have all this data and then suddenly I have a 0. So this one is very far away from 10. So, well, actually the mean will change a little bit, but this is very far away from the mean. So it would change S from 0 to dramatically larger. So it is not resistant to extreme. So the third property is S has the same unit as the original data. And also there is a statistical jargon. S is a biased estimator of population standard deviation. So if we want to estimate the population standard deviation, S is, we do not calculate S. So we'll talk about more about what is called a bias estimator in chapter like 5. Okay. If we are to compare standard deviation, we usually compare standard deviation with similar means. You don't compare standard deviation with the mean, which is different. So to compensate this, there is something called a coefficient of standard deviation, which is measured in percentage that describes standard deviation. Variation also, but it's out of scope of this class. So just remember, S will increase when data are more spread out. Okay, so I'm going to do a standard deviation hand calculation so you can get a feeling as to how to calculate standard deviation by hand. So usually we would plot the x value 15, 15, 17, 21. We move them here and then we add them together so we can find the mean. The mean is 15 plus 15 plus 17 plus 21. So if I use my scientific calculator, plus 15 plus 21, and I divide it by 4, it's 17, right? Actually, maybe I can just do use a I can use a decimal to do. Decimal can be your calculator here. So so we can do that, right? 15 plus 15 plus 17 plus 21 equal, and then divided by, oh, well, actually, close the parenthesis, divided by 4. Cool, right? No, that's 17. So, and then we go back and say, okay, so 17, where is it? So the second column would be all the data minus 17. So in this case, it's 17. So 15 minus 17 is -2. 15 minus 17 is -2. 17 minus 17 is 0. So look at how each data is away from 17 is 4. And then we square it. 4, 4, 0, 16. 2, -2 square, -2 square, 4 square. And then we add them together. 4 plus 4 plus 0 plus 16 divided by, should I divide by 4? No, we divide by 3. It should be divided by 3, right? Because it's n is 4. I have 4 data. Gosh, it's a mistake over there. So use my calculator. So it would be square root of 24 divided by 3. Oh, right. Yeah. So 4 plus 4 is 8. 8 plus 16 is 24. Divided by 3, 24 divided by 3 is 8. So this is correct. I just type it wrong here. So square root x is, so if you put in the calculator, is 2.8. Okay. So the standard deviation of this set of data, 15, 15, 17, 21 is 2.8. It looks very vague. It is not related to the mean at all. The mean is 17, but the standard deviation is 2.8. What does it mean? It just means that the data, a typical data, is 2.8 from the mean. 17 is the mean. A typical data is spread out by 2.8. So that's why we call it standard, 2.8, below or above. So around 2.8 of 17, you have a lot of data. So that is actually what it means. So how do we find standard deviation? And range, because we talk about having standard deviation and range being the two measure of variation, right? Bigger range means they are very, no, not bigger is not. So an example, do this by using statistics. I have a list of data like this, and I want to enter into statistics and calculate the standard deviation as well as range. So I think I already put it there. Let me see. Is that this? Yeah, did I put? Yeah, 5, 6, 3, 2, 6, 8, 10. If you look at the data that we have, yeah, 5, 6, 3, 2, 6, 8, 10, oh, 12, 17. Do I have that? Yeah, huh? 12, 17. So I have already put it there. And I run, so what do I run? I run data, descriptive, explore data. So 1, evaluate. So we calculate range. Range is at the bottom, 15. 15. And what is the standard deviation? Is right here, 4.7. 4.7. Okay. So let's put it here, 4.7 and 15. So that's 4.7. I should round it to 1 decimal place. The range is 15. So this is how you calculate it. Just use statistics. Oh, what about if it's grouped data? You do the same thing as we do for the mean. You enter this into the frequency distribution table generator. Generate a number using midpoint, and then find the standard deviation. So just do a quick example. So the data are 50, 60, right? 50, 60, 70, 80, 90. The upper is 59, 69, 79, 89, 99. Frequency is 1, 0, 0, 2, 4, 5. And then you go to the bottom, you generate the data. Let's say generate to 2. And then you do a descriptive statistics.